Hello, and welcome to your second lecture on lists and tuples. So just like with strings, lists can also use operations that we've previously seen with integers and floats, like plus and times. Let's quickly go to Atom and see how that would work. Okay, so we have a list, my list, and it has 1, 2, 3, 4, and 5 in it. Let's first think about what you think would happen if I printed out my list times 2. And there's lots of different things it could be, so think about what you think it might be. And when you're ready, unpause. Okay, I'm going to go ahead and run it. And you can see when we have multiplication, what happens is we take that list and repeat it the number of times that we multiplied. So here we multiplied by 2, so we have 2 copies of the list inside of a bigger list now. So basically, multiplying just repeats a list multiple times and combines that all into one list. Now that we've seen how multiplication works, let's think about how addition might work. So now I have 2 lists, my list with 1, 2, 3, 4, 5, and my list 2 with 5, 6, 7, 8. If I print my list plus my list 2, what do you think is going to happen? Think about it for a second, and then we'll go ahead and run it. All right, so you can see that when we add 2 lists together, we get a concatenation of those 2 lists. In other words, it takes the items in the first list and the items in the second list and puts them all together in one big list. Now, you may be thinking, oh, cool, okay, well, if I had my list and I just wanted to add the number 6 to it, I could maybe say print my list plus 6. Well, let's see what Python has to say about that. So when we run this, we get a type error, and that's because we can only add lists to other lists. We can't add a list to a string or a list to an int, which is what we tried to do in this case. If we wanted to do this, we could say 6 is in its own list, and now we're adding a list with another list, and that will work exactly as we expected it to. But remember, for now, you can only add 2 lists together. We'll learn how to add individual items of other types later on. Let's talk a little bit about list comparisons. So list comparisons, when using the greater than, less than, etc. operator, works very similarly to how it did with strings. First, the first item from each list, the 2 that are being compared, are compared. If they're the same, then we move to the next item and the next item until we find an item that is different between the 2 lists. Then we decide whether one is greater than or less than and return either true or false depending on what we find. For instance, if we had the comparison of these 2 lists where we have the string A and then the string ball, well, the first item in each list is the same, so Python would move on to the second item. This one is ball and this one is cat, so we would have to determine whether ball is greater than or less than cat. Well, ball is a string and cat is a string, so when we compare them, we would have to say, well, first letter of ball and first letter of cat, which is greater than or less than, well, ball is less than cat, so we would actually say that this list is less than this list. We can also use the equal to operator that shows up here, which allows us to check if 2 lists are exactly identical. And remember that if 2 lists are exactly the same, except one list has extra items, that list will always be greater. Let's go to Atom to see a couple of examples. So one of the operators that we're very familiar with is the equal to operator, and we can use this with lists as well as the other objects that we've used them with so far. In this case, this would return true because it's true that this list is exactly equal to this list. But we can also use some of the other comparison operators. For instance, we can say 1, 2, 3, 4 is greater than 1, 2, 3, 3. Now Python is going to walk through item by item until it finds an item that is different between the 2 lists. So for the first 3 items that it checks, it's going to be like, well, these 2 things are equal. When we get to the 4th item of each list, they're different. So now we can make a decision. 4 is greater than 3, so in this case, this first list is going to be greater than this second list. Now, remember that Python makes a decision as soon as it finds an item in both lists that are different. So for instance, we have this long list that says 1, 5, 2, 2, 2, 2, 2, 2, and then is less than this list 1, 6. Well, Python is going to say, okay, the first items are the same, so move on. Oh, okay, the second items, 5 and 6, are different. And it's going to make a decision here. So it's going to say that this first list is less than the second list because 5 is less than 6. It's not even going to consider these extra objects because it's already found an item where the lists are different. Just to prove ourselves right, let's go ahead and see what Python has to say about this. Awesome. So you can see that this list is indeed less than the second list, not because it's shorter, but because the first object that between the two lists is different. This one has a smaller one than the second list. It is now everyone's favorite time, and that is the time to talk about list methods. In some previous lectures, we learned about string methods, so we know that methods are just functions that are written specifically to work with a certain type of object. List methods, as the name implies, work with lists. Now, within the different types of list methods that we have modifying list methods and non-modifying list methods. Remember that lists are mutable, so we can actually change them after we've created them. Because of this, we can have functions that modify the list, but we can also still have functions that don't modify the list. Let's start with some non-modifying methods. In this case, we'll talk about index and count. Okay, so we have this list with apple, orange, cherry, apple, and apple. Maybe it's our grocery list. And we can use the non-modifying functions count and index. So count does what you might think it does. It counts the number of items in a list that are equal to the argument that we give it. So if we said l.count apple, and then printed that out, we should get 1, 2, 3, because there are 3 objects in this list that are equal to apple. So let's go ahead and save and see what Python says. Beautiful. Python agrees with us that there are 3 occurrences of apple in this list. Now notice, and I'll print it out here, that this doesn't actually change anything about the list. That's what we mean by non-modifying methods. The method does something, but it doesn't actually change the list in the process. Similarly, we can do this for index. We can say print l.index cherry. This will print out the index where we first find the object cherry, but it won't actually change the list. And to prove it, let's print it out. All right, so we can go ahead and do that. And it says that cherry is at index 2, which is 0, 1, 2. Yep, that's totally correct. Now, we can also do this with apple, and remember, apple comes up multiple times. So let's see what Python does with that. Okay, so you can see that when we call index for apple, which occurs multiple times in the list, it returns to us the first index that we see that item. In this case, it's index 0 because apple is the first item in the list. But again, in any of these cases, nothing is actually changing about our list. That's because these are non-modifying methods. They don't actually change the list itself. We do have a ton of modifying list methods though as well. Because lists are mutable, we often want to change them, and modifying methods help us do that. The most popular and common one that you're going to be using is the .append method. Remember that for methods, we say the object that we want to use, dot, and then the method. So let's say that we want to add something to our shopping list. I'm going to say the name of the list, .append. And then inside the append parentheses, I'm going to put what I would like to append to our list. In this case, I'm going to add another fruit. I'm going to add the cherimoya. And because this is a modifying method, we are actually changing our list. Notice we're not saying L equals L.append. We're simply saying L.append, and our list is going to change. To prove it, let's print out our list. All right, I'm going to go ahead and run that code. So you can see that our list is now changed. It is appended at the end our new fruit that we asked it to add. A list being able to be modified doesn't just mean we can add things. It also means we can remove them. One really common way to do that is with the pop method. Pop removes the last item in the list, but also returns it so that we could use it later. I'll show you what I mean. So we can say popped element, there we go, equals L.pop. And by default, it's going to pop off the last item in the list. We could also give it an index if we knew what we wanted to pop. And this is both going to modify our list and return the item that we've removed and store it in the variable popped element. So we're going to go ahead and print popped element and print L. All right, so we know what our list was before. Let's see what happens when we use .pop. Awesome, so we can see that the list now has removed the last item in the list, and it has returned it to us so that we could use it if we needed to. If we wanted to, we could have given this an index. For instance, if we wanted to pop the item at index 0, we could just give it 0 as an argument to the pop function. Let's go ahead and run that and see what that does. Awesome, so you can see that instead of popping the last item by default, it popped off the first item. So we no longer have apple at the beginning of our list, but we do have apple returned to us and is now stored in the popped element variable. Now, say that popping was a mistake and we actually want to add back apple to the first item in the list. We can do that using another modifying method called insert. Insert takes two arguments: the index that we want to insert an item into and the item that we actually want to insert. So we can say L.insert 0 because we want to insert it at index 0, and apple because that's the thing that we want to insert. When we're done with this, we can print out L to see how it modified our method. All right, let's go ahead. So we can see that our list used to have apple removed, but the insert function inserted apple at index 0 and moved everything else in our list over. We can also use the remove function, which will remove the first instance of something in a list. For instance, I can say L.remove orange, and we know that there is an orange at index 1 here. So when we do that, let's print L. This will remove orange from our list. Now, if we wanted to remove something like apple, where it occurs multiple times, remove will only remove the first instance of it. So we'll say L.remove apple, print L. And when we remove this, you can see that apple still occurs in our list, but the first instance of it has been removed. Now, the last of our modifying methods that we're going to talk about today is sort. Say we have this list, M, and it has a bunch of integers in it. Well, say we want those integers in order. We can say M.sort, print M, and when we do this, it's going to return to us this list of all of the sorted variables inside the list. Now notice, I'm not reassigning the list. I'm not saying M equals M.sort. M.sort is a modifying method, which means it changes the list and doesn't require us to return and set it equal to the variable again. Now that we've talked about methods, which are functions that are made to specifically work for the type lists, let's talk about some functions that we use a lot with lists but are not list methods. These include len, min, max, sum, and sorted. Let's talk about len. We can use len with strings as well, in which case it'll tell us the number of characters in our string. With lists, len will tell us the number of objects that are inside of our list. For instance, let's say print len m. This will tell us how many objects are inside the list m. So when we run this, you can see that there's 6 items, which makes sense because 1, 2, 3, 4, 5, 6. Next, let's talk about min and max. These are pretty self-explanatory. Min will tell you what the minimum value in a list is, and max will tell you what the maximum value is. For instance, we can say print min m and print max m. And when we do this, you can see that it prints the minimum 2 and the maximum 8 from our list. We can also take the sum of all of the items in the list. So let's say print sum m. This will take the sum of all of the items in our list, which is 2, 3, 4, 6, 7, and 8. So when we go ahead and run this, we get that the sum is 30. So when you add 2, 3, 4, 6, 7, and 8, you get 30. All right, last but not least, let's talk about our last list function, sorted. You might be saying, Chelsea, didn't we just talk about a modifying list method called sort? Isn't this the same thing? Kind of, but not really. Remember that modifying list methods actually change the list. So if we have our list, let's put it out of order again. We can say print sorted m, and then print m When we run this, it'll print out a sorted version of the list for us, but it doesn't actually modify the list. When we print out M after printing sorted, the list is still in its non-sorted form. That's the main difference that you want to think about with sort versus sorted. List.sort will actually modify the actual list, whereas printing sorted M is actually going to print out, or it'll return a sorted list for you, but it doesn't inherently change the list. If we wanted to do that, we'd have to say M equals sorted M, in which case this is now very similar to the .sort method. This seems like a good time to just review. Remember, modifying list methods actually change our lists. Functions and non-modifying list methods don't. However, they may return things like the minimum, the maximum, or even a sorted list that we can then store in other variables for us to use later. Okay, let's revisit the split method, which is actually a string method, but since it returns a list, I wanted to talk about it here. If we have a string and we use the .split method, it's going to split our string into multiple substrings, a list of multiple substrings. So, for instance, if we say print our words after splitting, this is going to print out a list of all the words in this sentence. So let's go ahead and comment this out. And when we go ahead and run this, you can see that it returns to us a list of all the words in our sentence. This is really useful because sometimes we want to loop through words and change some, and then we eventually might want to join our individual strings into a bigger string again. We can use that with the .join function. Now, .join counterintuitively is also a string method. And remember, string methods, you say the string that you want to do them to, the name of the method. So if we want to join our individual strings that we have here back into a bigger string, we're first going to say the string we want to use to join them back together. So say instead of having spaces between our words, we want to change this into something that looks like a variable name. So we want underscores between each of our words instead of spaces. We're going to give a string of what we want to separate each word, and then we're going to say .join, and then we're going to give it a list of all the words or all the strings that we would like to join. In this case, it's stored in our words, and we're going to go ahead and print our variable so that we can store it, and then let's print it out. Print our variable. All right, let's go ahead and see what this prints out. Great, so we can see that we have now joined together all of the individual words, but now with underscores instead of spaces. So again, split and join are string methods, not list methods, but because the .split method returns a list and the .join method takes in a list, I wanted to cover them here because it'll be very useful when we want to loop through each word in a string. Okay, let's do one exercise together. So we're going to create a list of 5 words that have 5 or more letters. I've done that here and stored it in some words. Then we're going to use the function randint 0 to len list -1 to choose a random word from our list. Basically, what this is going to do is choose a random integer between the first item that you give it and the second item that you give it. We're basically going to use this to choose the index of whatever word that we want to choose. All right, before we actually do any of the other steps, I just want to show you how the random.randint function works. So I'm going to go ahead and print out random.randint 0 to the length of our list here. So we're going to say len of some words, and this is going to choose a random index from 0 to the length of the list. So when we run this, you can see that it's chosen 4 this time. If we run it again, it'll choose another random one, 3. If we do another one, 1, etc. So you can see 0, 1, 2, 3, 4. It's choosing an index between 0 and 4, which essentially means we can use it to select one of the words to use. All right, so now I'm going to, instead of just printing it out, store this index that we've selected to indicate which word from this list that we've chosen. Then let's move to the next step, which is convert this string into a list. Well, I can do that by saying letter list equals some words bracket I. That's saying from this list, choose the one of the random index that we chose. And I'm going to turn this into a list of letters. I'm going to do that using list. And this is going to give us a list of all of the letters in that word. I'm just going to print that out so you can see what it looks like. So we'll say letter list. Beautiful. Cool, so you can see that in this case we've chosen kaleidoscope, and it has now created a list where each of the individual letters is now an individual item in letter list. All right, now that we have all of our letters in a list, we can use random.shuffle to shuffle that list. So we're going to say random.shuffle letter list, and let's go ahead and print out letter list so we can see what that does. So basically, this time it chose balloon. We're shuffling the letters in that word so that they're in a different order. In essence, we're creating an anagram. However, our letters are still in a list, and maybe we want to join them back into a string. We can do that using the join function. Let's say word equals empty string, because we don't want anything between the letters, dot join letter list. Beautiful, and then let's finally print out word. All right, when we go ahead and run this, you can see that we now have an anagram for the word that we selected, balloon. That's all that I have for you. I will see you next time.